Okay, I will share the page. എന്താ പഠിക്കുന്നത്? എടുക്കാൻ എന്താണ് നെറ്റിൻ്റെ പ്രശ്നം? ഇതാണ് നമ്മൾ പഠിച്ചുകൊണ്ടിരിക്കുന്ന പേജ്. Net is very weak today, that's why taking time. So today our aim is to find electric field intensity at P due to the dipole. Here which is the dipole? AB. AB, name of the dipole is AB. What is its length? 2A. What are the charges? Minus Q plus Q. Which is the center point of the dipole? O is the center point of the dipole. So what we have here? A dipole which is having minus Q and plus Q and separated by a distance 2A. And what is our aim? We have to find electric field intensity at P. We know when a charge is kept, there is an electric field around it. When two charges are kept, here two charges are there. Dipole is having two charges. When two charges are kept here, at this point, there will be field due to both the charges. Minus Q charge will have a field, plus Q charge will have a field. And we have to find the net electric field due to both the charges. That is, so both the field you have to find out. What is the field due to minus Q charge? What is the field due to plus Q charge? Both you have to find, and you have to find vector sum of both the field. That will be the resultant electric field at the point P. So children, what is our aim? Maharunisa, what is our aim? Vagamara.
To find the electric field intensity
at P along the axial line due to what? Due to both the charges. Okay. First we are finding electric field intensity at P due to minus Q charge. Let us find it first. That is done here. Let vector E1 is the electric field intensity at P due to the charge minus Q which is placed at A. Then we know the formula for electric field 1 by 4 pi epsilon 0 Q by R square. That is the equation. So you should know what is the distance between minus Q and P. And we already marked distance from center to the point P as R. R is the distance of this point P from the center of the dipole, small letter R. And this distance, total distance AB is 2A. So O is the midpoint of AB. Then what will be AO? What will be AO, children? A, small letter A. Okay, small letter A. So what is the distance from A to P? What is the distance from A to P? R plus A. R plus A, correct. A minus Q to this point. That is A to P, the distance is R plus A. So R plus A, instead of AP, you have to write R plus A, AP square is there. So R plus A whole square you have to write. So we are writing the modulus. And the direction separately we write which direction it acts, that we write separately. So you have to write modulus here because we are writing magnitude and direction separately you are writing. Okay, that method is done here. So modulus vector E1 is equal to 1 by 4 pi epsilon 0 q by, this is q, this q by distance square, AP square. AP is r plus a, r plus a whole square. Along the direction you should know. This is a very small positive test charge. This is, according to this definition, this will be the source charge. We know dipole is a very small charge, but this is the source charge. This is the test charge. So this test charge will experience a force in which direction? Unit positive charge it is. Test charge will experience a force due to minus q charge. This test charge will experience a force. Which direction? Mitra, which direction this test charge will experience a force? Towards this charge or away from this charge? It will be towards. It will be experiencing a force towards this. And that is the direction of electric field. Which direction the unit positive charge experience a force, that will be the direction of electric field intensity. So along PA, that's why we have marked it along PA. See, the dark line it is represented. From point P we have marked a vector E1 along the direction PA. This is E1. Okay. Next we have to find out electric field density at P due to plus Q charge. Okay, children, this is plus Q charge. What is the distance of this charge from P? What is the distance? Center to this point is R. But we have to find only this distance, BP. What is BP here? R minus A. So BP is R minus A. Understand? So we can write the formula modulus of vector E2 equal to 1 by 4 pi epsilon 0 q by BP square, 1 by 4 pi epsilon 0 q by R minus A whole square. R minus C, but from here to here it is R. But we need only this distance. So it is R minus A. BP only we need in this expression. So we write R minus A whole square. Okay. Children, did you understand both the steps?
Yes, ma'am.
Okay. Direction we should tell. What's the direction of vector E2? That means when a unit positive test charge is kept here, unit positive, very small charge is kept here, it will experience a force. In which direction it will experience a force? I will ask to Adilashmi, which direction it will experience a force? Positive charge experience due to this positive charge. This positive charge, this is smaller charge. This smaller positive charge experience a force. Which direction? Due to this charge. Adilashmi is there?
Yes, teacher.
Then tell which direction it will experience a force, this positive unit positive charge. Towards right or towards left? This
right.
is positive. Towards right. Right, very good. Why it is moving towards right?
Because it is positive charge.
There will be force of
repulsion.
Repulsion, correct. So it will experience a force along Px. We can tell towards right, that is Px. Let us take that as Px. Along Px, that is written here. Here it is written along Px. Now, how will you find the resultant field? Look in this figure. Which is greater? First you should tell that. One is denominator r plus a whole square. For this one E2, it is denominator r minus a whole square. Which will be greater? Denominator, this is smaller. Here the denominator is bigger. So quantity, which quantity will be bigger, E1 or E2? For example, 10 by 2 or 10 by 5 ആണോ വലുത്? 10 by 2. 2 എന്ന് പറഞ്ഞാൽ തീർക്കാം നമുക്ക് ചെറുത്. 10 by 2, 10 by 5. ഇത് 10 by 2. അപ്പോൾ എത്രയാ? ഒരു എക്സാമ്പിൾ പറയാണ് 10 divided by 2 എത്രയാണ്? അതും മിണ്ടൂല.
10 by 2 is greater.
5 ആണ് അല്ലേ? ഇത് 10 by 5 ആണെങ്കിൽ ഇത് 2 ആണ്. അപ്പൊ ഡിനോമിനേറ്റർ വലുതാകുമ്പോ ക്വാണ്ടിറ്റി ചെറുതാവും. അപ്പൊ ഇവിടെ ഡിനോമിനേറ്റർ വലുത് ഇതിന്റെ അല്ലേ? അപ്പൊ E1 ആണോ E2 ആണോ? ഡിനോമിനേറ്റർ വലുതായ ക്വാണ്ടിറ്റി ഏതാ ഗ്രേറ്റർ?
E2.
E2 ആണ് ഗ്രേറ്റർ. ഡിനോമിനേറ്റർ ചെറുതാകുമ്പോൾ പാടിച്ചു വലുത്. അപ്പോൾ E2 ഗ്രേറ്റർ ആണ്. ഇനി ഈ ഫിഗറിലൊന്ന് നോക്കിയേ. കണ്ടോ, ഞാനത് ലോങ്ങർ വെക്ടർ കൊണ്ടാണ് റെപ്രസെൻ്റ് ചെയ്യുന്നത്. കണ്ടോ, അപ്പോൾ നിങ്ങളും അത് വരയ്ക്കുമ്പോൾ ശ്രദ്ധിക്കണം, ഒരേ ലെങ്ത്തിൽ വരച്ച് വെക്കരുത് കേട്ടോ. E2 ഈസ് ഗ്രേറ്റർ. കണ്ടോ, ദിസ് ഈസ് ഗ്രേറ്റർ ലെങ്ത്. വി ഹാവ് ടു റെപ്രസെൻറ്റ് E2 വിത്ത് എ ലോങ്ങർ ലെങ്ത് ആൻഡ് E1 സ്മോളർ ലെങ്ത്. And we know these two are acting at the same point in opposite direction, but magnitudes are not equal. How will you find the resultant, children? Anyone? How will you find the resultant of E1 and E2? Adding, subtracting, parallelogram. What will you do? Tell.
Subtracting E2
subtracting. Greater minus smaller. For example, I'll tell another example. Suppose here Jnana Prakasham is standing here, and the Bangsha is pulling to this side. Which is stronger one? Midun is pulling to this side. In which direction? Here the Midun is pulling with a greater force. Okay? The Bangsha is pulling with a less smaller force than that. Which direction Jnana Prakasham will move?
Right direction.
Towards right direction. That's greater. Greater vector minus smaller vector ആയിരിക്കും resultant field, resultant force. നമ്മൾ നേരത്തെ പറഞ്ഞ example, it is resultant force. Here we have to find resultant field. So you have to subtract E2 minus E1. E2 minus E1 you have to find out. So we can do that step. So only that is mathematical part, very easy to do. Yes?
ഡയറക്ഷൻ ഓപ്പോസിറ്റ് ആയതുകൊണ്ടാണ്
ഒരേ ലൈനിൽ, സെയിം ലൈനിലാണ്, ഓപ്പോസിറ്റ് ഡയറക്ഷനിലാണ് ആക്ട് ചെയ്യുന്നത്. മനസ്സിലായില്ലേ? അപ്പൊ ഞാൻ ഈ പറഞ്ഞ ആഡ് ചെയ്യണം. അപ്പൊ ആഡ് ചെയ്യാം. E1 plus E2 എന്ന് എഴുതണം കേട്ടോ. അങ്ങനത്തെ കേസൊക്കെ വരുന്നുണ്ട് നമ്മൾ പഠിക്കുന്നതിൻ്റെ ഇടയ്ക്ക് കേട്ടോ. ഓക്കെ. പിന്നെ ഇംഗ്ലൈൻഡ് ആകുമ്പോഴാണ് നമ്മൾ പാരലലോഗ്രാമും ഒക്കെ ഉപയോഗിക്കുന്നത്. ഇംഗ്ലൈൻഡ് ആകുമ്പോൾ കേട്ടോ. Any doubt?
P electric dipole positive negative separate ചെയ്ത് വെച്ചു. P ഇത്ര ഡിസ്റ്റൻസ്, ഇവർ രണ്ടുപേരും തമ്മിൽ അട്രാക്ഷൻ പോലും, അപ്പൊ ഡിസ്റ്റൻസ് കൂടൂലേ?
Dipole is separate. Anyway, there is a force which is separating them. Understand? Actually I didn't hear your question, and from what I understood I am telling you.
Ma'am, അതെ, ഇപ്പോ പ്ലസ് മൈനസ് ക്യൂവും പ്ലസ് ക്യൂവും തമ്മിൽ ഒരു അട്രാക്ഷൻ ഉണ്ടാവൂലേ? അപ്പൊ അട്രാക്ഷൻ ഉണ്ടാവുമ്പോ ആ പി എന്ന് പറഞ്ഞ ഒരു പോയിന്റ് ചാർജിന്റെ ഡിസ്റ്റൻസ് കൂടൂലേ എന്നാ ചോദിച്ചേ മാം.
Point charge, ഇല്ല, they are separated by a distance. That is not changing. Understand? Dipole is that you should have that idea. Two charges are separated. They are kept like that. In the atom of molecule of water, molecule of carbon, it is situated like that. No, distance is not changing between them.
പിന്നെ മാം ഈ പ്ലസ് ക്യൂവിന്റെ അവിടെ മൈനസ് ക്യൂവിന്റെ അവിടെ പ്ലസ് ക്യൂ വെച്ച് കഴിഞ്ഞാല് ഈ ഫോർമുല മൊത്തത്തിൽ മാറൂലേ?
മാറും. നമ്മളെപ്പോഴും ഇങ്ങനെ എടുക്കാൻ കാരണം ഡൈപോൾ മൊമെന്റിന്റെ ഡയറക്ഷൻ മൈനസ് ക്യൂ ടു പ്ലസ് ക്യൂ ആയതുകൊണ്ട് മിക്കവാറും എല്ലാ ഡെറിവേഷനിലും നമ്മൾ ഇങ്ങനെ തന്നെയാണ് എഴുതുന്നത് കേട്ടോ. അപ്പം അതൊന്ന് ശ്രദ്ധിച്ചാൽ നമുക്ക് തെറ്റ് വരില്ല. മൈനസ് ആദ്യം എഴുതുക, പ്ലസ് പിന്നെ എഴുതുക കേട്ടോ. മൈനസ് ക്യൂ ടു പ്ലസ് ക്യൂ ആണ് ഡൈപോൾ മൊമെന്റിന്റെ ഡയറക്ഷൻ, അതുകൊണ്ടാണ്. ഓക്കെ, അപ്പോൾ നമുക്ക് റിസൾട്ടന്റ് ഫീൽഡ് വി ക്യാൻ ഫൈൻഡ് ദ റിസൾട്ടന്റ് ഫീൽഡ് ഓൺലി മാത്തമാറ്റിക്സ് ഉണ്ടാവും. E2 is greater than E1, so E equal to E2 minus E1. 1 by 4 pi epsilon 0 q by r minus a whole square minus 1 by 4 pi epsilon 0 q by r plus a whole square. Next, common factor is taken outside. Q by 4 pi epsilon 0 q by 4 pi epsilon 0 and 1 by r minus a whole square minus 1 by r plus a whole square. Next, a plus b into a minus b, we know a square minus b square. So whole square is there. A square minus b square whole square. R square minus a square whole square. Then here this is LCM is taken. So here we get r plus a whole square minus here we get r minus a whole square. Then what is there? we have to a plus b whole square expansion, a square plus 2ab plus b square, that expansion is done here, r square plus 2ar plus s square minus s square a minus b whole square, s square minus 2ab plus b square. This is simple mathematics, r square minus 2ar plus a square, okay. Then this with this minus sign you multiply, minus r square plus 2ar minus a square, it is written, r square cancels, plus a square minus a square cancels, and what remains? 4ar, 2ar plus 2ar, 4ar divided by r square minus a square whole square, that remains along with this. So what is next done? You can see 4ar, q by 4 pi epsilon 0, 4ar by r square minus a square whole square. Then q into 2a, see this is splitted in this form, 2a into 2r, like that. So 4ar itself, but it is splitted in this form, 2a into 2r. Why do you know? Because q into 2a is dipole moment. That's why we have taken 2a from this and written like this, q into 2a into 2r. So q into 2a is dipole moment p. Modulus is written. Modulus of vector p is q into 2a.
ഈ dipole momentന്റെ equation model ആക്കിയതാണോ 2a?
Yes, that's why we have changed in that form. Okay, and we have to write the final expression in terms of the dipole moment. So modulus of vector E is equal to modulus of vector P by 4 pi epsilon 0 2r by r square minus a square whole square. Tomorrow I will ask this derivation, and everybody write 2 times this derivation along with this expression. Tomorrow I will check whether you wrote it or not. Okay, here onwards you have to study every derivations very well, and the formulas, whenever I ask you should be able to tell what is the electric field intensity along the axial line of a dipole, 1 by 4 pi epsilon 0 2 pr by r square minus a square whole square along px, along the axial line and away from it, that is along px. So whenever I ask this question, it must be in your mind. What is the electric field density along the axial line? By heart it. Understood? So derivation study very well. And a final expression very important. At any time you should be able to tell what is the electric field density along the axial line of a dipole. This is the expression. And there is a special case for that, by heart it, by telling it 10 times, 20 times, by heart it. Understand? So if a dipole is short, 2a is very less than r. Dipole is short, length is very short, and r is larger than that. And I will show you the figure. In this figure, when dipole is short means this point, this distance is very large. P is at a very large distance from the dipole. We can neglect A. That is what we are going to do. When the dipole is short, what is the expression? When the dipole is short, A can be neglected. See, a square, see this term is neglected. A is neglected, so a square is also, because this is a very small distance. Size of the dipole is very short, because molecule, atom, like that. So the distance is very small. When we square it, it becomes too small. Understand? Then again square is there. So that's why we neglect a square. Okay. So P into 2r by 4 pi epsilon 0 r is to 4 only is taken. 1 r get cancelled, we get 2 by 4 pi epsilon 0 p by r cube. Modulus vector p by r cube. Direction is same along px. So some questions they will tell what is the electric field intensity due to a short dipole. If it is asked, you have to write this expression. Special case, when the dipole is short. For example, problems and all, they will not give the length of the dipole, and they simply tell that it is a short dipole. So A is not there in the expression. A is not there. So if the dipole is short, its length we are not considering. We get the expression 1 by 4 pi epsilon 0 2 p by r cube. Okay. So for that also you have to by heart. This is the usual case, and when it is special, when dipole is short, we get 1 by 4 pi epsilon 0 2 p by r cube. Everybody write to take a rough book for that, for writing the physics derivations every day. And once in a week, I will hold a meeting to check that whether you are writing it or writing it and studying. So now to check that, I'll hold a meeting and asking questions also. One meeting will be for that. Okay. Google Meet I will call, and 1 hour we will get like that. Every week I think like that. Okay, next is electric field intensity. Any doubt in this, children? You can tell in steps. Any doubt?
Ma'am, what is E proportional to 1 by R square?
Which this one. Okay. Electric field R cube electric field 1 by R cube along the axial line. It is inversely proportional to R cube. R cube the note correct R cube inversely proportional to R cube. Clear? Mitra?
Yes, teacher.
Okay. Any other doubt, children? In this derivation, very important derivation. It's a 2-mark question. When both the derivations asked together, it is a 5-mark question like that. See, anyhow, whether corona is there or not, this exam will be there. CBSE now also they are planning to conduct the exam. So exam will be there. We take it seriously, all the exams, all the this class test, unit test, everything you have to take seriously. We don't know what will happen. So average of these marks, sometimes they may consider in 10th, you see, they have taken like that, internal marks. So each and every exam takes seriously. Okay, now we can find electric field intensity along the equatorial line of electric dipole. This also very important derivation. Let us see what is the electric field intensity along the equatorial line of dipole. That also very important diagram. This is the diagram. Who is waiting? No. I'll explain the figure. So first, see, this is the figure. Here you can see a dipole. Dipole is AB. Name of the dipole is AB. 2 charges, equal and opposite charges, minus Q plus Q, separated by a distance 2A. Clear? And what is our aim? First of all, you should know what we are going to do. We are going to find electric field intensity at P. Where is P lying? P is along the equatorial line. What is equatorial line? It is the perpendicular bisector drawn. Perpendicular bisector. See, Y is the midpoint. We have drawn a perpendicular here and we have taken a point P on this equatorial line. So you understood what is equatorial line? It is the perpendicular bisector drawn to the dipole. So AB is the dipole. First, what will you explain? AB is a dipole consisting of charges minus Q and plus Q, which are separated by a distance 2A. O is the center of the dipole. Whenever we tell about a point, P is a point where along the equatorial line, at what distance? It is at a distance small r from O. Understand? So this is the figure explanation. Figure explanation is very important. Well, otherwise there is no meaning. What you have written, well, nobody knows. Don't think, yeah, teacher knows this, so I don't want to write this. Don't think like that. When you draw a figure, everything you must explain. What is this? What is this? See, AB is a dipole. And what this denote? Minus with the charging, minus Q and plus Q. And what is 2A? 2A is the distance between the two charges. What is O? O is the center of the dipole. What is R? R is the distance from O to the point P. What is the importance of P? P is at, see, P at P. We want to find the electric field intensity. Axial line we have already found the intensity. What is the electric field intensity at P? Along the equatorial line. What is the electric field density? Both charges are kept here. Both charge will have its own field. What is the net field at P? That we have to find out. Net field. Understand? So let us find the net field at P due to both the charges. If only single charge is there, what's the formula? E is equal to 1 by 4 pi epsilon 0 q by r square. But here it is not a single charge. Two charges, two equal and opposite charges are kept here. And along the bisector, along the equatorial line, with at a distance r from the dipole, what is the electric net field? What is the net electric field intensity at P due to this dipole? That is what we have to find out. And first we can find out what is electric. I will ask questions to you. Okay, you have to tell the equation. What is the electric field intensity at P due to minus q charge? For that, you should know the distance from minus q to P. Here we are keeping the unit positive charge. What is the equation? What is the equation? ചോദിക്കാത്ത ആൾക്കാർക്ക് Adityan, tell what is the equation? Adityan, what is the electric field intensity at P due to minus q charge? Equation പറ. ആദിത്യൻ, ഞാൻ വീട്ടിലേക്ക് വിളിക്കുന്നുണ്ട് കേട്ടോ ആദിത്യനെ. ഇങ്ങനെ ശരിയാവില്ല, ഒരെണ്ണത്തിന് ഒന്നും മിണ്ടാണ്ട് ഇങ്ങനെ ഇരുന്നോളൂ. അഭിനവിനോട് നേരത്തെ ചോദിച്ചാണ്, വേറെ കേട്ടെ. അക്ഷയ, ടെൽ വാട്ട് ഈസ് ഇലക്ട്രിക് ഫീൽഡ് ഇന്റൻസിറ്റി അറ്റ് പി? ഇക്വേഷൻ പറ.
1/4
എപ്സിലോൺ 0
q
ബൈ ദാറ്റ് ഡിസ്റ്റൻസ്. എന്താണ് ഈ ഡിസ്റ്റൻസ്? ഇവിടെ തൊട്ട് ഇവിടെ വരെയുള്ള ഡിസ്റ്റൻസ് ആണ് എടുക്കേണ്ടത്. ആറല്ല, ഇവിടെ ആർ സ്ക്വയർ കറക്റ്റ്. അതായത് റൂട്ട് വരില്ലേ? അതായത് പൈതഗോറസ് തിയറം വെച്ചിട്ട് ദിസ് ഡിസ്റ്റൻസ് ഈസ് ആർ, ദിസ് ഡിസ്റ്റൻസ് ഈസ് എ. അപ്പോൾ ഈ ഡിസ്റ്റൻസ് എന്താണ്? ദിസ് ഡിസ്റ്റൻസ് സ്ക്വയർ ഈക്വൽ ടു എയോ സ്ക്വയർ പ്ലസ് ഒ പി സ്ക്വയർ. അപ്പോൾ ഡിസ്റ്റൻസ് എന്ന് പറയുമ്പോൾ സ്ക്വയർ റൂട്ട് വരും, ഡിസ്റ്റൻസ് സ്ക്വയർ പറയുമ്പോൾ റൂട്ട് പോവും. അപ്പോൾ ഈ ഇതെന്താണ്? എ പി എന്നുള്ള ഡിസ്റ്റൻസ് എന്താണ് അക്ഷയ? റൂട്ട് ഓഫ്
ആർ സ്ക്വയർ പ്ലസ് എ സ്ക്വയർ.
ആർ സ്ക്വയർ പ്ലസ് എ സ്ക്വയർ ആണ്. ഇത് എ സ്ക്വയർ, ഇത് ആർ സ്ക്വയർ. അപ്പോൾ ഇത് റൂട്ട് ഓഫ് ആർ സ്ക്വയർ പ്ലസ് എ സ്ക്വയർ ആയിരിക്കും അല്ലേ? കറക്റ്റ് അല്ലേ? കണ്ട, എ പി സ്ക്വയർ ഈക്വൽ ടു ഒ പി സ്ക്വയർ പ്ലസ് ഒ എ സ്ക്വയർ. എ പി സ്ക്വയർ എന്ന് പറഞ്ഞാൽ പൈതഗോറസ് തിയറം വെച്ച് എ പി സ്ക്വയർ ഈക്വൽ ടു എ ഒ സ്ക്വയർ പ്ലസ് ഒ പി സ്ക്വയർ. അതാണ് ഇവിടെ എഴുതിയിരിക്കുന്നത്. കണ്ട, ആർ സ്ക്വയർ പ്ലസ് എ സ്ക്വയർ. അപ്പോൾ നമുക്ക് ആ ഡിസ്റ്റൻസ് ഇതാ 1/4 pi epsilon 0 q by r square plus x square. അപ്പോൾ magnitude we got. Then along which direction? Only 5 more minutes. Okay. Which direction? Aparna, tell which direction it will experience that force? ചാർജ് ഇവിടെ പോസിറ്റീവ് ചാർജ്, ഇവിടെ നെഗറ്റീവ് ചാർജ്. അപ്പോൾ എങ്ങോട്ടായിരിക്കും? അപർണ ഉണ്ടോ? അപർണ? അതിൽ കൃഷ്ണ, വിച്ച് ഡയറക്ഷൻ ഇറ്റ് എക്സ്പീരിയൻസ് ഫോഴ്സ്? ഇഫ് ഇവിടെ ഒരു പോസിറ്റീവ് ടെസ്റ്റ് ചാർജ് വെച്ചാൽ അത് എങ്ങോട്ടായിരിക്കും? പറ. വിച്ച് ഡയറക്ഷൻ a unit positive charge kept here will experience a force due to this minus q charge? അട്രാക്ഷൻ ആയിരിക്കോ റിപ്പൽഷൻ ആയിരിക്കോ? ഇവിടെ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് വയ്ക്കും, ഇവിടെ മൈനസ് ക്യൂ ആണ്. അപ്പം ഏത് ഡയറക്ഷനിലായിരിക്കും ഫോഴ്സ് എക്സ്പീരിയൻസ് ചെയ്യുക? ഈ ചാർജ് ഇവിടെ വയ്ക്കുന്ന ചാർജ് അട്രാക്റ്റീവ് ആണോ റിപ്പൽസീവ് ആണോ? തെറ്റിട്ടാ, ഇവിടെ പോസിറ്റീവ് വെക്കണം എന്നല്ലേ ടീച്ചർ പറഞ്ഞത്? ഇവിടെ പോസിറ്റീവ് അല്ലേ, അപ്പൊ ഇവിടെ മൈനസ് അല്ലേ, അപ്പൊ റിപ്പൽസീവ് ആണോ ആവുക? ഇവിടെ പോസിറ്റീവ്, ഇത് നെഗറ്റീവ്. അപ്പൊ എന്തായിരിക്കും? അട്രാക്ഷൻ അല്ലേ? അപ്പൊ പോസിറ്റീവ് ചാർജിന്റെ ഇങ്ങോട്ട് എക്സ്പീരിയൻസ്. അപ്പൊ അലോങ് ദി ഡയറക്ഷൻ പി ഡയറക്ഷൻ പറ. അലോങ് ദി ലൈൻ ജോയിനിങ് ദ ടു ചാർജ് അല്ലേ? പി എഫ് ആണോ അല്ലെങ്കിൽ പി സി ആണോ? അല്ലെങ്കിൽ പി ആർ ആണോ? പറ, നിങ്ങളുടെയാണ് എക്സ്പീരിയൻസ് ചെയ്യുക. ഇവിടെ വെച്ചിരിക്കുന്ന പോസിറ്റീവ് ചാർജ്, ദ ചാർജ് വിച്ച് ഇസ് കെപ്റ്റ് ഹിയർ, യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് വിൽ എക്സ്പീരിയൻസ് എ ഫോഴ്സ് വിച്ച് ഡയറക്ഷൻ? The direction of force is same as direction of electric field. Adil Krishna, please tell which direction it will be attracted, along which line it acts.
PA ആണോ ടീച്ചർ?
PA, it will experience a force along PA. Clear? That means we have represented that green colored vector PA along that line it acts, so we represented PC. And you know PC will have two components along this PO and along PR, two components. This angle is theta, so we have marked this angle as theta. And you know, if this angle is theta, this angle also will be theta. This theta ആണ്, equilateral triangle പോലെ ഇരിക്കുന്നത്. അപ്പോൾ ഇതെല്ലാ ആംഗിളും ഈക്വൽ ആയിരിക്കും. This theta, പിന്നെ this one will be theta, this one will be theta. Theta ആയിരിക്കും. അപ്പോൾ two component. First you understood this component. Along PC it acts electric field, and it will have two component. Green colored line are the components. One component along PO, other component along PR we have got. Okay, and next we have to find electric field intensity at P due to plus Q charge. Okay, I'll ask to the other one. Gautam, tell, when a unit positive charge is kept here, it will, due to this positive charge, it experience a force. Which direction? Gautam?
Yes, ma'am.
When a unit positive charge is kept here, in which direction it will experience a force due to this charge? Here, for unit positive charge, this is a plus Q charge. Which direction it will experience? Away. That means along the line.
Because it's positive.
Positive. Along the line are marked there. Along which line it acts? Tell. Hello? Line joining the two charge and away from it.
D.
What is it? PD, correct. Along the same line joining the two charge and away from it. PD, correct answer. Along PD. And here PD also will have two components. Vector E2 we have represented. It will have two components. One component along PF and other component along PE. Understand? So two component it is also having, and you know this PO component and PF component will cancel. They are equal and opposite. They will cancel because you know the magnitudes are same. I will show you the magnitude. E1 is 1 by 4 pi epsilon 0 q by r square plus s square. What is E2? Devika, what is E2? Devika, what is E?
Yes, ma'am.
What is the magnitude of E2?
1 by
4 pi epsilon 0
by epsilon 0 q by r square minus a plus
r square
a square
r square
plus
plus a square. Same as E1 is